All right, let's go. What an important day this is. Not because it's April 9th, that has no significance. What's important about it is that today you learn how to factor. And by the way, I told you this a while ago. Factoring is so big, like there's so many different flavors of this. So today we are very specifically talking about factoring only one type, and they are called quadratic trinomials. So as I said, there's going to come a day where you take algebra 2 maybe, and you wind up factoring all sorts of different types of things. But at the end of the day, the word factoring is just, it's got a very simple definition. To factor something means to break it down into things that multiply to make it. You've been factoring since like fourth grade. You just didn't factor algebra expressions. But I imagine starting in about fourth grade, you had a teacher that had you make one of these. And I don't know if you want to write this down. You may look back at this and get confused, but do you remember factor trees?
Oh,
And I don't know if your teachers called them factor trees, but when we break things down into multiplicative pieces, like, well, give me two numbers that make 12. I'll take it. You just factored, right? And then you could take the six and break it down into what? Two and three. Like you just factored again. So you've been factoring for years, just not in the same way necessarily that you are going to do today. But well, hi. The idea behind factoring, don't lose sight of that as we work today, is just to break something down into two or more things that multiply together to make it. Okay. So having said that, what we're going to do today is exactly literally the opposite of what we've been doing for the last 2 days. In the last 2 days, I gave you binomials and said, hey, would you multiply these together? And then you get answers. And when you're done, your answers look like this. This is where you should start writing things down again. So for the last 2 days, what you've known as the answer is today going to be the question. The question becomes, what multiplication problem would have had to exist so that if I worked it out, if I foiled it, it would give me this answer. And you're going to get, you may not believe me, you're going to get hundreds of practice problems on this over the next few days, literally hundreds. And so the process is pretty, it's kind of repeatable, predictable. It's very, very algorithmic, like it never changes. So the first thing we're going to do is think about what would have to go where those arrows are pointing to make x squared and another x, right? So we're already starting to construct, we're filling those empty shells. I say this a lot, build the shells. So inside the shells, we're going to put the things that would have to be multiplied to make what we want to get. And now we consider, this is usually where the trouble could begin. In these two blanks right here are going to go two numbers, including two signs. So there will be either a plus, a minus and a minus, a plus and a minus, or a minus and a plus. What do you think they're going to be? For sure, just pluses. There would be absolutely no reason to put a minus here. Just imagine for a second, I wouldn't write this down if I were you, but imagine I put like a -3 and a +5. What is that when I multiply those together? What's -3 times +5? -15, and I'm cooked, right? Because I was trying to make a +15. So looking at that number in the back and that yellow egg is where you're going to decide what signs should I use. Okay. So I agree with what you guys said, that they're going to be pluses. So the next thing I do is put in my pluses, and then you go through all the things you know that multiply to make 15.
3 and 5.
And it will be 3 and 5. And we can make a strong case and say that that's the right answer because of this and this. What does the purple make? 3x. What does the green make? Add 3x and 5x. What do you get? Everything checks out. If you were to go back through the whole four-step foiling process with this, you'd say that works. That's how you factor a quadratic trinomial. They're going to get harder, of course, but that's the fundamental idea is you just fill the shells with things that will make everything happen the way you want it to happen, right? Yes, sir. What an interesting thing. Yeah, I've been telling kids that for years. Thank you. You've seen the light, my man. I don't know if you heard what he said. You can literally grade your own papers. Like someday soon, a week or so, you'll take a test on this. And you can literally grade your own paper before you turn it in. If you just do what Riley said, you can go through the whole four-step FOIL process. You can go this times this times this times this times this. And if it equals this, you just graded your own paper. Top-notch thinking. Yeah, so that's a fun thing about factoring is you can grade it yourself. Let's go again. So I use this expression a lot, build the shells. So when someone says, "Hey, I don't know where to start," well, you start here. You know what your factors are going to look like. Each of those parenthesis sets is called a factor. They're the things that are multiplying to make my initial uh, problem. So factors as nouns are the things we're about to build. The process of finding them, ironically, is called factoring, right? So how do I start? Put two x's in there because I know I need an x times an x to make x squared. Now let's be smart about this. Looking at the yellow egg in the back, tell me about the signs I'm going to need. I need one of each because no matter what, at the end of the day, and this is where 99% of the mistakes happen is this conversation here. No matter how hard you try to deny this fact, whatever I put in those two blanks have to multiply to make negative 16. And the only way to accomplish that is to make sure I have one of each, right? If you're talking about the negative 6 in the middle, we're not ready for that conversation yet. What's important is that we lock in on the signs. And now you go through and you think about all the numbers that multiply to make 16. And I know you're ready to give it to me back there, but give me just one more second here. Sure, fire away, buddy.
Does it matter which?
It will eventually. The order that you put them in doesn't matter in a case like this, but it will in the fourth example and from then on out. So you'll see. Like Riley said, just check it and you'll see. You can always just go back and remultiply what you have. I believe that a couple hands, maybe you found the numbers that we're looking for. Did you find them?
I have if you do a +2 and then like a -8. If you do that, it'd be -8 plus +2.
Right. And good job, Alyssa. And the idea, oh wait, I mean good job, HQ. The thing about this is I'm not going to waste my time checking this times this because I put them there. I know they equal x squared. I'm not a dum-dum, and I'm not going to waste my time checking this because I put them there. I'm not a dum-dum. I know they make minus 16. That's not what I'm interested. That's not what I'm here for. I'm here for the purple and the green. That's where the flow and the dynamic of this happens. What does the green make in the middle? What does the green make, or the yellow, or the purple in the middle? I'm sorry, plus 2x, right? What does the green on the outside make? And you add those together, and guess what you get? Exactly what we wanted, which means that that's the final answer. Okay, let's do one more warm up, and then I'm going to put a number in the front, and that's when it gets a little bit trickier. So, Gunnar, I need you to stay awake. Hey, Julian, would you smack him, please? Knock it off, dude. Build your shells, right? A good factor knows that you want to like create your workspace. And so we're going to go with an X and an X. Now, signs. I'm not worried about the 32 and the 12. I'm not worried about any of that. I'm worried about signs. I've done this long enough to know that it's all about the signs. Tell me about what I'll need for this job. Let's problem solve this together. The numbers that we pick have to multiply to make a positive. And in mathematics, there are two ways. If I said to Macy, hey, Macy, write me a multiplication problem, I just want the answer to equal a positive. She'd have a couple of options at her disposal. One of them is she could do a positive times a positive, couldn't she? But isn't there another way? She could do a negative times another negative. And so this is the only time we're going to default or defer to the one in the middle. The 12 is usually something I don't much care about. But in this case, I need to look at the 12 and say, hey, Holmes, I need to take a look at your sign because whatever your sign is clearly the one that I have to use twice. So normally the 12 is unimportant. He will just work on him at the end. But this time I need his help to tell me what the signs are going to be. Because the 32 in the back is like not in and of itself enough information.
So the signs are different. Go with the first one.
I don't, I'm telling you that if the number in back is a positive, then that means the two signs that we put here and here have to be the same. And knowing same isn't enough information. That's where I go a step deeper and I look at where the red arrow is pointing and I steal that sign.
Okay.
Got it? So you start by looking at the term in the back, the 32. And if he's positive, then you need to look at the one in the middle because he's going to spill the full beans. Got it? And there's the structure. And then you go through and you think about all the ways you know to multiply to make 32. And there's not all that many of them. There's going to be 1 and 32, there's 2 and 16, and then there's 4 and 8, and that's it. What are we looking for? I want to do the -4 and the -8. Because when I check these, what does purple make? -4 x's, and what does green make? -8, and when you add those together, there's your -12. So that's the warm up. That would be what I would call a level 1, where it's just there's no number in front of x squared. Do you have any questions yet? Okay. So now it gets a little bit trickier. So the problem with those first three examples is that some people fall asleep. They listen for 7 minutes and they go, oh, I'm done. You just want me to find two numbers that multiply to make this and add to make this. I'm done. You know, wake me up when it's over. That doesn't work now. And it won't work most of the time because of this guy. The little demon in this problem is the 3. Yay, it's a crusher. So let's start by building our shells. Think smart. This time, what has to go at the front of my shells? I need a 3x and a 1x. Very good. What about my signs? Two positives. And again, that was a team effort there between the 20 and the 32. The 20 started us knowing that they both have to be the same. The 32 backed them up and said, oh yeah, BT dubs, they're both pluses. Okay. Now we run through all the lists of all the ways to make 20. By the way, I have a sheet for you today that I'll hand out in a little bit. Have I ever given you one of these? I gave you one of these earlier this year, right? So if you've lost it, I'll give you a fresh one. But we're going to want this out when we factor because a lot of times when the numbers get bigger, it's like, oh, I got to find all the numbers that make like 72. And there's a lot. So if you have this, great. If you don't, I'll give you one here in a little bit. But it has all your times tables up through 100, which super useful for factoring. What numbers are catching your... Let's go through the list. There's 1 and 20, and then the backwards of that, 20 and 1. It matters now. 2 and 10, 10 and 2, 4 and 5, or 5 and 4. Anything jump out? You're not going to find any numbers on this list that add to make 32. So if that's where the confusion starts, is like, none of them add to make. I get that, but the 3 is in play now. And what happens is, think about it. Whatever number you put over in this red blank, think about this. Whatever you put there is going to multiply by 3, and it's going to get what I call a buff. So you see, I can buff something. So what do you think I should put in that red blank? You want me to put a 10 in the red blank? Let's try it. What would that leave going in this other blank? A 2. And so the red number gets a buff, you see. Again, I'm not interested in this. I know what that makes. And I know what that makes. I put them there. I'm not interested. I'm interested in the purple and the green. What does purple make? Ah, 30x. And what does green make? Add those together. It works. So again, we're not looking for numbers that in and of themselves complete the task. It becomes a team effort. All the numbers in the problem together start working in harmony to make magic happen. Nice job on that one. It was a good team effort, though. Okay, let's go again. Step one,
Okay.
build your shells. Step two,
Do it.
good. If you came to me anywhere before this and said, I don't know what to do, I would kind of look at you a little funny, like we haven't really done anything yet. Building the shells is just following directions. And then we know that the only way to make 2 is 2 times 1. So it has to be a 2x's and a 1x to make 2x. There's no other way, right? This is where we can get stuck. Let's take a look at yellow egg. He's everything I need. I don't need to look at the 11. I don't care about the 11. What does the 40 with a negative on it tell me? Say again. One has to be a positive and one has to be a negative. And back to JoJo's question from about 10 minutes ago, does it matter what order they go in? Now it does. And so make sure you're always using a pencil when you do factoring, because we might wind up in a position where we feel like we've got it, but we have to switch the plus and the minus to make it work. So lots of eraser usage when we do factoring. What do you want to try? I mean, you know all the numbers that make 40. I'll write them down anyways because I'm nice, but there's 1 and 40 in backwards, and then there's 2 and 20 in backwards, and then there's 4 and 10 in backwards, and then there's 5 and 8 in backwards, right? Those are all, so there's 8 factor pairs of 40, 4 and then the 4 backwards ones. Anything jump out? Say again? Sure. A good factor goes like YOLO, and you just try. The worst factors are the ones that stare at it and go, I'm just not seeing it. It's okay. Just make a mess. That's what erasers are for. Let's try this and see if it works. We will realize here in about 20 seconds that this is not even close, and that's totally normal. It's totally par for the course around this place. So again, I'm not interested in the easy parts. I'm interested in this and this. And again, going back to Riley, can I grade it myself? Yep, that's what I'm about to do. What does the purple make on the far outside? A minus 10x. And what does the green make on the inside? And negative 10 plus 8 is negative 2, not even close to what we wanted. We want negative 11. It's okay. What else should we try?
Do the, positive, like, +5 and.
Okay, so you're saying keep the same numbers, just acknowledge that putting them in different places can make a big difference. Smart. Don't throw them out if they don't work the first try. Switch them, because that might be all the doctor ordered. What does the purple on the outside make now? Minus 16 x's. And what does the green make on the inside? And what's minus 16 plus 5? Jackpot. Done. And then last one on level 2, and then we're going level 3. So step 1, make your shelves. Step 2. Yep. So everybody gets this far. Then we pause. And Riley is on his A game today. He says, I'm thinking it's going to be 2 minuses. And the reasoning goes back to the yellow egg doesn't tell me the answer. He just tells me that they both have to be the same. That's not enough information. And that's when I go, hey, buddy, I go look at my neighbor and say, oh, thanks for the info. We're both minuses. Now we scour our knowledge and we think about numbers that multiply to make 54. What's the most common factor pair you know from like fourth or fifth grade that makes 54? 9 and 6 is your guy. That's the first one that people think about when they think 54. There are others, but let's start with the obvious first, 9 and 6. Let's give it a shot. Where do you want me to put them? Because there is a difference if I put the 6 here and the 9 here, or the 9 here and the 6 here. As we saw in the last problem, it makes a world of difference. 6 and then 9? Sure. So let's check our purple and our green. I would recommend you get some colored pens if you're the kind of person that's into this, and really start stressing the purple green to yourself, or make them the same color. Go like purple, purple. I don't care, but stress to yourself that I want the O and the I. The outside and the inside is where I grade my paper. What does purple make? Minus 63 X's. And I already know it's wrong because I'm going to blow down even further now, but let's just to make it official. The other one makes a minus 6X, and that's minus 69X. So we've gone too far. So thoughts? Switch them. What do the ones on the outside make? Inside? Add them together? Jackpot. And now step 3, level 3. You good? You will know fairly quickly why this is level 3. Step 1,
Shelf.
I'd like you to take a moment and look at the board. And it took 7 examples for this to happen, but on the 7th example, I just built 2 sets of shells. Why? Why? Because of the 9. And 9 is the first time we have seen a number in this red box that is not a prime number, meaning there's more than one way to make 9. If it was a 7, we knew it was a 7 and a 1. 2 is 2 and 1. 3 is 3 and 1. 5 is 5 and 1. 11 is 11 and 1. But 9, this is where it gets a little rougher. It could be a 9x times an x, or what else? So we're going to have multiple templates to work with here. Yeah, no negatives to be found. So now not only do we have the annoyance of trial and error, but now we have the annoyance of trial and error in multiple templates. But the good news is I started you off with a nice softball one here because what are the signs? We know they're plus and plus. We can just get that in right now. And what are the only 2 numbers that multiply to make 5? Yeah, so I mean, the winner here is either going to be a 1 and a 5 or a 5 and a 1. So there are 4 things we have to check. Top template 1551, bottom template 1551. And if you're a math person, you already see it. The number 46 is screaming at you because you know your times tables, and 46 is yelling at you. How can I get to 46? If I put the red number here, good job, Hoffman, it gets a buff. And knowing your times tables is huge because look at the buff. That's not just any buff. That's a proximity buff. What's 9x times 5? 45. And 45 is pretty close to 46, right? And then you get it with the 1x. You finish the job there with the 1x. Okay. So some problems will give you clues like that. Good job. Okay. Still feeling good? Example. Fantastic. I did this to you on purpose. I made sure that these 2 examples for our level 3 warm-ups would both have the same number in front. So step 1, build your shells. Unfortunately, I do need multiple sets of shells. And again, my options are 9x and 1x, or maybe the break one, 3x and 3x. What are my signs this time? Got to be one of each because of the yellow egg. Yellow egg is all I need. He says if I'm a negative, one of each. So this is going to be a way step up in difficulty because now we have to consider the plus, minus, or maybe it's a minus and a plus, plus, minus, or maybe it's a minus and a plus. And then on top of that, we have to consider that there's multiple ways to make 8. So we could be looking at 1, 8, 8, 1, 2, 4, 4, 2. And when you factor in all those options with the signs and the multiple templates, we've kind of entered the danger zone here. So let's work together. And by let's, I pretty much mean you guys. Get in there and make a mess. That's what erasers are for. Try something. I'm going to try something and I want you to tell me if you think it's intelligent. No, what I just did is really not very smart, huh? Because that 8's going to take a buff, huh? What's 8 times 9? 72. And I blew right past 6. I'm like, how am I going to get back to 6x that I'm trying to make? So there are, yes, a lot of options, but there are also quite a few really not very smart ones. So think about that as you go. It's not completely random. Did you find it, Riley?
No,
Sure, fire away, man.
did you make like 4 like, sets of shells?
If you wanted to,
Right.
absolutely.
That's all.
Sure. I'm just going to get rid of my signs like this, and I'm just going to go, I'm going to put one of each because if we figure out we're right on it, then we'll just switch the signs. But if you want 4 completely different templates, yeah, go ahead, man. Anybody find it yet, Jojo? Which template are you in, Joe? Okay, so you want -4. Uh, so we're still in so 4 here and then 2 here. I'll take it. I'm not holding out on you here. There's no magic revelation where I go, okay, today's the day. I'm going to show you the secret. You'll be factoring when you're 19 years old, sitting in a college class somewhere like on campus, and it still comes down to trial and error. No matter how many YouTube videos you watch with people that draw squares and X's, there is still a point in time where you have to find some combination of numbers that works magic. You'll find you can watch 100 videos hear it explained 100 ways. It still comes back to some luck. Yeah. So 9x plus 8 and x minus 1. I'll take it. Let's take a look and let's test the handiwork here. What does the purple make? -9x plus 8x makes -1x. We missed the mark. Totally normal. Yes?
For the second, the bottom template, 3x plus 4, 3x minus 2.
So 3x, you want a +4 and a -2. Let's check Alyssa's handiwork and see. Again, you cannot ever, I've seen people go, oh, maybe I should like put 2 minuses. Give me a break. You can't break the rules of math when you get desperate. Like we have to keep a positive and a negative. But what Hoffman's come up with over here is magic. Ready? Multiply purple. What do you get? Plus 12x. Multiply green. What do you get? What's 12x minus 6x? We have a winner. That's what factoring can feel like. You can feel like alone and lost and like, man, what am I doing here? It can take some time and it'll get even a lot worse than that. Okay. Be patient with the process. It is trial and error. Last one, and then I'm gonna let you try some on your own, and I'll try to save what little time we have left. Step 1. shells. And I'm going to again need two templates because there are two ways to make 10. So I'm going to need the easy break and the full break. Tell me about my signs. They're both negatives because they multiply to make the yellow egg. So they have to be either two negatives or two positives. And then 17 says, I got you. So this is nice. I don't have to guess on my signs. And there's not a whole lot of ways to make six. There's 1 times 6, 6 times 1, 2 times 3, 3 times 2. So as a team, let's go figure it out. Again, I'll take one for the team here. Putting a 6 here would be silly because it buffs to minus 60x. And I'm like, yeah, that's what am I thinking? Putting really any large number across where the red number is pretty silly, right? So let me know when you find it. And again, staring at it isn't the way. I appreciate that you want to, but like really just getting in there and getting your hands dirty. Uh-huh.
Okay.
Like this.
Yeah.
No. I love the way you thought about that though, because your brain saw a 20 and a 3. And you're like, booyah, 20 and 3, but they're both negatives. Right. Yep. That's probably where I would have gone too. So good effort on that though. You should really be gravitating to the bottom template. And the logic behind it is if I put either a 2 or a 3 or a 6, they all get buffed and we go past our negative 17. So the only other option in the top template would be if maybe a 1 worked and then a 6 here, but that's minus 10 minus 6, which is minus 16. So we can prove pretty quickly that the top template is no bueno. Day 10? I don't know. Let's try it. Let's find out. 2 and 3. Let's see if it works. Uh, did I? That doesn't quite work, does it? That's minus 4x and minus 15x. Uh-huh. Did you find it? Let's try it. As you've seen, the worst that can happen is it's wrong, right? Like boo. Outside purple, what did they make? Minus 5x. Inside green, what do they make? Add those together. Jackpot. That, my friends, is how you factor quadratic trinomials. Okay. We've got only 6 minutes right now. I want you to bust out your old Chromebooks. I want you to flip them open and I want you to go to Delta Math. Let's just set a goal. Let's see if every one of us can get a couple of them right before the bell rings. That would be pretty rad, huh?